have supply and transformer primary, and then have some secondary. This will work for full wave center type rectifier, because for the project you need that circuit. So let's start. Full wave is also same, I mean the output is same, so we'll work with full wave center type. Diodes. Two experiments together, right? Feedback circuit. We'll have full wave center tap. We'll see the output with this. That full wave center tap output will be the input of our feedback circuit, and then we'll filter it and we'll see the steady DC. That's what it will be our job. So there will be two experiments in a package. Okay. Then we'll have the resistor connected. Up to this is a full wave rectifier, full wave center tap. So once we have input like this here, okay, then we'll see an output like this here. Okay, this would be the form of output. And one most important thing to say that the frequency. If there is a question like that I would ask you that the amplitude is 5 of a signal, how the signal will look like when the amplitude is 10, then you have to just maybe this is 5 amplitude, 0, 5, 0, minus 5, 0, 5, 0, minus 5, that's how it is. And when it becomes 10, that means the amplitude is this, right? This will increase to 10. So you have to show something like this. And again, there might be question like, if the frequency is set to 50 Hertz to a full wave rectifier, what would be the output frequency? Listen, in a full wave rectifier, the frequency will become double. That means if we have 50 Hertz frequency set here, and the input of a full wave rectifier, we see at the output we have 100 Hertz frequency. That means frequency will always be double. That means number of cycle per second will be double, because let's see how. Why that happened? In this, we have only one positive half, right? Within this time. At the same time, we have two positive half. That makes the frequency double. You understand? Okay. Now, after this, we discussed that how that happens. We talked in a class that how full wave takes place. Okay. Now, filter. This is called pulsating DC. This is AC. And with this maybe 0, 5, 0, minus 5. So for our experiment, we will take 9 volt. So let's see, 0, 9, transformer output will be, okay, this is 0 to 20. Once transformer is stepping down this to 9 volt. So now it will become, this is 220, high amplitude. 0 to 20, 0, minus 20, like this, that line voltage. Then once we use the transformer, this voltage will step down to some 0, 9, 0, minus 9, 0, 9, 0, minus 9, like this, right? And once we rectify this voltage, this alternating signal, this will become 0, 9, 0, 9, 0, 9, like this. So we have a state like this, 0, 9, 0, 9, 0, 9. Okay, now our job is just to make it a constant steady voltage, which will be 0, always 9, 9, 9. There will be no break, no 0 in between, just 9. So we are in a state for now. This looks like here. Okay, let me do it here because we will complete the circuit. So we are in a state that looks like 9, then 0, and again 0, 9, then here 0, here 9. So if you start from here, that looks like 9, 0, 9, 0, okay, got it?
Yes.
And then again 9. So that's how it looks like, and then 0, and then finally 9. But we want something here that looks like 9, 9, 9, 9. So we have this form of pulsating DC output. This is DC. Okay, this is DC, but pulsating, there is a pulse because the voltage which start from 0 and come to the peak, and again getting down to the 0, and again rise up to peak, and again getting down to 0. So there is still some AC component. AC was like changing, right? So there is still some change. Obviously it is in one direction, that is why we call it is DC, but still there is some change in. That's what we call ripple. Okay, so once we remove the ripple, then it becomes a steady 9, always 9. All the moment it is 9. There is no 0 involved.